Any suggestions? Let me know. We will take a look at, let's take a look at a unit circle. Okay. So the unit circle right here, again, let me know if you've got any math questions. Okay, a unit circle is on an XY plane. It has a radius of 1. So in the unit circle, this right here has an X value of 1, a Y value of 0. And as we go around, because the unit circle has a radius of 1, we know the X and the Y values are all going to be really nice numbers like this. Okay, any questions? Let me know. Anything? Okay, anything math related? Let's get after it. All right, so what I'm going to do is I'm going to take a look at some of the different degree angles. So this right here, that's a 45-degree angle. Okay, I know that because it's half of 90 degrees. That's always easy. And then we can go another 45, and that gets us 135 degrees. All right, and then we can go up to 180. Now, when we look at the unit circle, we're going to be dealing with something called radians, okay? Radians. So if I were to go ahead and take this radius, all right, 1 unit long, and I were to lay it along the edge of the circumference of the circle, this opening right here, this opening would be 1 radian. Okay, so 1 radian is just equal to the opening created by laying 1 radius along the arc of a circle. That's a radian. Is it still an angle? Yes. Is it in degrees? No. That's why you have to have radian mode in your calculator. If you got any questions, let me know. Any type of math problems, okay, we can shift, no big deal. All right, so if that's 1 radian, if you were to lay all the radii across the circle like this, along the edge of the circle, you would end up with about 6.28 radians. That would equal a full circle. All right? All right, that would equal a full circle. So, in essence, 1 circle around is going to be 2 pi radians. So, 360 degrees equals 2 pi radians. Okay? That's essential in order to understand where radians come from and why they're important. Okay? So 2 pi radians are in 360 degrees. All right? Now, if we have 360 degrees is 2 pi radians, let's go ahead and figure out, okay, what is 90 degrees? So if we know that 360 degrees equals 2 pi radians, then what is 90 degrees? Well, that's pretty straightforward, okay, because we know that 180 degrees right here is just half of 2 pi, so that's just going to give me pi radians. Now, everything is a fraction based off of this scenario. So because 360 is 2 pi radians, then I can go ahead and I can say, all right, 360 is 2 pi radians, then 180 is just pi radians. Well, then 90 is just pi over 2 radians, and 45 degrees is just pi over 4 radians. Okay? So let's say again, we got 0 radians, 45, pi over 2, okay? And then 1 pi radians. Hey, let me know. There's 6 of you in here. If there's anything you want me to pivot off to, I got no problem. All right, we've done ACT paths in the past, whatever you'd like. All right, so I got 45 pi over 2. Now, if this is pi over 4, and this is pi over 2, and this is pi, we can figure out how many radians that value is. But before we do that, let's go ahead and do the rest of the circle. So this is 0. We know that 360 degrees is 2 pi radians. So this is 0, this is pi over 2, this is pi, So let's look at it. 0, 1 pi over 2, 2 pi over 2. This is going to be 3 pi over 2, which is the same thing as 270 degrees. And then this right here is 2 pi, or 360 degrees. All right? So this is 1 pi over 4, 45 degrees. This is 2 pi over 4, pi over 2. This right here is going to be 3 pi over 4. This is just counting, folks. So this is 3 pi over 4, and this is going to be 135 degrees. As you get further and further after pre-calculus into your calculus, the degrees is going to matter less and less. All right, you use more degrees on the ACT than you do anywhere else. All right. Sometimes in physics too, I suppose. 180 degrees. So this is 1 pi or 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Get it? 4 pi over 4 is 1 pi. So this right here is 5 pi over 4. All right, this is going to be 225 degrees. I'm just adding 45 to the 180. And then this one right here, 270, it's going to be 6 pi over 4, aka 3 pi over 2. And this right here, it's going to be 7 pi over 4, and that's going to be 8 pi over 4, which is just 2 pi. The unit circle is really easy. It really is. Let me know if there's anything else you want to see on, you got any tests coming up, let me know. All right, so now what we're going to do is we're going to take a look at the 30-degree angles. So the unit circle has basically, we've got the 90 degrees, then we've got the 45 degrees, and then we've got the 30 degrees. All right, so if this is 30 degrees, and I've got pi to get to 180, how many 30-degree angles are in 180? Okay, there ends up being 6. So, because 6 times 3 is 180. So this is going to be pi over 6. So 30 degrees is pi over 6 radians. 60 degrees is going to be 2 pi over 6 radians, which is the same thing as pi over 3. So it's 1 pi over 6, 2 pi over 6. This ends up being 3 pi over 6, which is pi over 2. And then right here, this 120 degrees ends up being, so this is 1 pi over 6, 2 pi over 6, 3, 4 pi over 6, which is 2 pi over 3. Okay, but I'm just counting. When I first teach this, kids, I don't care whether they reduced or not. 1 pi, 2, 3, 4. So then this one is going to be 5 pi over 6. 5 pi over 6, which ends up being 150 degrees. All right, then we've got 6 pi over 6, and we keep going. Hey, let me know if there is any other math stuff you want to go over. We can switch over, no big deal. All right, this is 180, so this is 210 degrees. All right, we've got 5 pi over 6, 7 pi over 6. Sorry, 6 pi over 6. This one's going to be 7 pi over 6. All right, then this one right here is going to be 8 pi over 6. 4 pi over 3 if I reduce. All right, and then this 225 degrees, I'm going to just go ahead and add 30 to the 180. So it's 210. This is 240. And again, we've got 270. The pattern goes. All right, so I've got 8 pi over 6, 9 pi over 6, which is 3 pi over 2, back at 270. All right, we're going to go ahead here. This is going to be 300 degrees. So we've got 8 pi over 6, 9 pi over 6. This is 10 pi over 6, or 5 pi over 3. And this right here is going to be 330. And this is going to be 10 pi over 6. So it's going to be 11 pi over 6. And then 360 is back to 12 pi over 6. The whole thing is just a pattern. The whole thing is just a pattern. Let me know if you've got anything else you want to look at. All right, I'm going to go into the different x and y values of the unit circle. Okay, let me know if there's anything else. All right, so let's take a look at just the first quadrant of our unit circle. All right, so we're setting here our unit circle. All right, so what we're going to take a look at is let's take a look at first a pi over 4. Okay, so pi over 4 is the same thing as 45 degrees. What we're going to do here is we're going to create a triangle. So we've got this triangle right here. Okay, I'm going to kind of draw it right here. That's a right triangle, and this right here is 45 degrees. Okay, what we have right here is we have a special right triangle. We have a 45, 45, 90 triangle. Why is that special? Because we've got x root 2 in terms of the ratio of the sides. All right? So what's the one thing we know about this unit circle? What is the one measurement we know on here? We don't know the x, we don't know the y, but we do know that the radius is 1. So our hypotenuse is going to be 1 here. So what happens is we end up getting this to be x, this to be x, and 1 to equaling x root 2. Okay? And if we have 1 equaling x root 2, what we can do then is we can go ahead and say, all right, if x root 2 equals 1, what does x equal? Right? If some of you have already studied this unit circle, you want to know, hey, how do they get those weird numbers? This is how. So I'm going to go ahead and I'm going to divide by the square root of 2. Right? So those cancel. I have to rationalize that denominator. So I have x equals 1 over the square root of 2. So I got to rationalize that denominator. So I got square root of 2 over the square root of 2. So I end up getting x equals square root of 2 over 2. Okay. So what that means is, in my right triangle right here, this x and that x is no longer x, but it is square root of 2 over 2. Why is that important? Well, when I go ahead and I place these values over here on my triangle, I end up getting specific lengths. Okay, well, what do we mean by specific lengths? Okay, trig, well, overall algebra 2. Let me know anything specific. What type of trig? Okay, we can go from there. This is technically trig, but maybe a little less so. So what we've got is we've got this value right here. That's the y value. So the y value at pi over 4 is square root of 2 over 2. Okay, and then what we've got is we've got the x value at pi over 4 is square root of 2 over 2. All right. So when it comes to the x and the y value at pi over 4 radians, it's square root of 2 over 2. And the question is why? Well, it's right here. It's a special right triangle. Okay. All right, let's take a look at another scenario. All right, hey, if you need any help with anything else, let me know. I can adjust. Nobody asked me to do unit circle. I just thoroughly enjoy it. So let me know. I take this into March everything, and trig confuses me. Functions confuse me too. All right, well, what I can do is I can take a look at, I've got some SAT or ACT practice here. I've done some trig functions before. All right. I don't have anything here. Wait. Some trig ACT. Well, here, let's just go with it. So let's say we've got a triangle here. And they give us the fact that this is 35 degrees. Okay. And then they say, okay, this has got a right triangle. Let's say this is 1.7. All right. Find x. All right, let's start at the basics. So what we're going to do is we're going to look at SOHCAHTOA. All right. Now, if this is a little too basic, let me know. All right. SOHCAHTOA. So what this means is we've got the sine of an angle right here is 35 degrees, is always equal to the opposite over the hypotenuse. All right, now the question is, what is the hypotenuse? What is the opposite? The hypotenuse is always going to be across from the right angle. So this is my hypotenuse. Okay, now what is the opposite? Well, whatever opposite side is an opposite from the angle. So this right here is opposite 35 degrees. So that would be this one. Unfortunately for this example, we cannot use sine. We do not know the opposite. So what we have to do is we have to take a look at a different one. What about cosine? All right, let's take a look at cosine. Cosine equals adjacent, this A right here. So this acronym, this is what it's for. It's adjacent over hypotenuse. And what that means is so adjacent, is like if I'm sitting adjacent to somebody, I'm sitting next to them. So this right here is the adjacent side to the angle. See 35 degrees, opposite side, adjacent. So what I do is I take the cosine of 35 degrees equals adjacent side 1.7 divided by the hypotenuse, x. All right, this one's the more confusing one, especially when we get into trying to figure out what x is, because it's on the bottom. So what I'm going to do is I'm going to go ahead and take both sides, I'm going to times it by x. All right, so you end up getting this equation. So then I've got x cosine 35 equals 1.7. And then what I'm going to do is I'm going to go ahead and divide by the cosine of 35. Oh, cosine of 35 degrees. So then my x value is, take my TI-84. If you don't have this calculator is very good because you can press this alpha x and I get a fraction button. Very, very good. So I get 1.7 divided by, now I'm going to go ahead and make sure I'm in degrees. Right here I'm in radians. Some of your calculators are going to be in radians. You got to put them in degrees. All right, so I'm going to do my fraction button. I'm going to do 1.7 divided by the cosine of 35 degrees. All right, so I'm getting 2.075 for my answer. So what is my hypotenuse if I know that this is 35 and that side is 1.7? X equals 2.075. All right, let me know, is there any other math questions you want me to work on? Any other topics that you might be going through? All right, so let me know. All right, so I'm just taking a look at some trig problems. All right, so I got another one here. Let me know if there's any other problems you want me to go through, any other topics you're working on in class. Let me know. Okay. All right, so what we've got is in a right triangle below, the measure of angle C is 90 degrees. So we've got something that looks like this. So the measure of angle C is 90 degrees. We've got the angle B. This is 2. This is 5. And this is A. It says, what is the tangent of B? All right, here we go. So we got to find the tangent of B right here. So in our SOHCAHTOA, TOA. This means the tangent of an angle. So tangent of angle B. Tangent of angle B is going to be a ratio every time of the opposite side over the adjacent side. So no matter what size, right triangle, it's the same ratio. So we're going to use the fact that that ratio is a specific number that we can get from our calculator, and we're going to use it on this specific problem here. So I've got the tangent of B equal to, all right, so now I need the opposite. So this would be my opposite side. Okay, and then this is my adjacent side. So that means we have to figure out what our opposite side is using good old Pythagorean theorem, of course. So I have 2 squared plus, let's just call this x. 2 squared plus x squared equals 5 squared. All right, so that gives me 4 plus x squared equals 25. So then I get x squared equals 21. So I get x equals the square root of 21. Now, technically, it's plus or minus, but, you know, I'm going to keep it positive because we have a distance. Now, in our answer key, or for the multiple choice, it's got like square roots in it. All right, so this is what it wants. It wants to find the correct square root. So this is the square root of 21. So my answer would be the tangent of B equals opposite over adjacent. Okay. A little bit of trig action at you. All right, let me know if there's anything else you guys want me to look at. All right. Willing to look at any problems, any types of problems, even up to calculus? Let me know, let me know, let me know. All right. Anything else? More trig? I can do. I was doing the unit circle. Okay. Functions like f of x. Okay, so there's a lot. There's a lot with functions. Like let's say something like this. So let's say f of x equals 3x plus 4, and then g of x. So I'm guessing this is something like this. So then g of x equals x plus 1 divided by 3. Okay? So functions like this, is that what you're talking about? Now, what I'm going to do is, a lot of times they want me to find f of g of x. Okay? They want me to find f of g of x. So here's what you have to think of. So f of x is just another name for y, like y equals. So is g of x. Mathematicians name it something funny so that they can name different functions, different letters, and this right here signifies the input. So I have to do this. I do this every time. So if I've got f of star, I don't care what it is, star plus tree, okay? This function says I take whatever's in this parentheses, I times it by 3 and add 4. So if I had star plus tree in here, then I'm going to take 3 times star plus tree. Okay, I'm going to add 4. So that's all a function. It's like, okay, this is my input. I'm going to put that in there because that's what my function does. Times it by 3, add 4. All right. So if it wants f of g of x, what I'm going to do is I'm going to do f of, and instead of putting the g of x there, I'm going to write what g of x is. So g of x is this sucker, right? That's not very fun. But it doesn't have to be this huge thing if we can just understand that this is my new input. I take whatever my input is and I times it by 3 and I add 4. Oh, calculus 2. I can do a little bit of calculus 2, absolutely. So let's do 3 times x plus 1 divided by 3 and then plus 4. So those 3's are going to cancel. So I get x plus 1 plus 4. So I get x plus 5. All right, so that's what it is in terms of f of g of x. So I'm just taking this function, plugging it in for g, and then doing whatever the f function tells me. Now, if I got an x here, let's say I just got x, these two would be inverses. All right, those two would be inverse. I'm guessing if it was plus 4, right, x minus 4 divided by 3 would be inverses. All right, so that's how you do f of g of x. Okay. Let me know what you're thinking for Calc 2. All right, let's do another one. Let's do. I'm gonna look up a ACT question with functions or SAT. All right, so all right, sweet. Well, there's a lot of struggle with the graph. So let's take a look at this. So we've got a graph here of your standard, XY plane, and it looks like it goes up to 3. So we're gonna do a trig graph. Okay, trig graphs are always something kids don't like. I don't blame them, to be honest. Oh, bumped my camera there. All right, so I've got this is pi over 2. So that means this is pi over 4. Excuse me. All right, so this is pi over 2. This is going to give me pi, and then vice versa. And then I've got, going to go down like this. All right, integrate. All right, let me just put this down here. E to the 6 sine 7 theta. It's giving me some trouble. D theta. All right, just give me a second. Let me finish this one. I'll take a peek at that one. All right, going down like that. All right, tells me what is the equation of this thing. All right, so the first thing I look for is any horizontal shifts left and right. I can't find when to stop when integrating by parts. That's what I was looking at. I was like, oh, looks like integration by parts, but there's a lot going on there. But we'll try it. We'll see what we can do. All right. So for this one, I look to see if there's any shifts. It doesn't give me. So like x, minus whatever pi over 2 x plus. So it asks for, in terms of the equation, what's the number in front? So it's y equals, the number in front is going to be how high it goes or how low it goes. Okay, notice how the middle of my graph is right here. Like right here, it goes up 3, down 3. You got to find the middle of your graph, because if the middle of your graph is like up here, then we kind of have to adjust what our amplitude is. So our amplitude here is going to be 3. Okay, it's always, okay, 3 is, it's up here. Now it could be negative, if we were dealing with like a moved over sine graph, but it doesn't look like that here. So the fact that it starts up here, I'm thinking it's a cosine graph, because usually the cosine graph is, if we have the unit circle right here, I'm not sure if you guys do the unit circle in algebra 2, but the unit circle starts right here at 1, 0. The x value is a cosine value, so it starts at 1. So it goes right here. Now, right here, this is the period. So from peak to peak is called the period. So to find the period, we're going to do 2 pi divided by what our period is here. So it looks like our period is pi. So that means the number in front, okay, is going to be 2. So I think what we're looking at is 3 cosine of 2x. So this 2 comes from this right here. This 2 comes from that. All right. All right. Let's take a look at this integration problem. All right. So I'm a high school math teacher who does teach Calc 2, although probably for sure the hardest subject to teach. All right. So we've got the integral. Yep. E to the 6 sine 7 theta d theta. All right. All right, so we've got a product, so we're thinking integration by parts. All right, so we use LIAT, right? We've got logarithm, we've got inverse, algebra, then we've got trig and exponential. So it looks like we're going to deal with algebra, so we're going to do e to the 6. Okay. So what I've got is I've got u equals e to the 6. So we've got du equaling, wait, is it e to the 6? Is it 6 theta? e to the 6th theta. That makes more sense. Okay. So we've got u equaling e to the 6th theta, right? E to the 6th theta, I would assume. Okay. So e to the 6th theta. So then we've got e to the 6th theta times 6 theta. We never use theta for our variables. All right. So if I take the derivative of that, and then so I've got 6 e to the 6th theta d theta, and then I've got dv is going to give me 1/7 sine. I'm in college calc. Are you in high school or are you in college taking college calc too? 7 theta. So that means I'm going to take, oh shoot, this isn't 1/7. dv is just going to be 7 theta. So once I take the integral, then it's going to be 1/7 cosine 7 theta. Okay. College, taking college, gotcha. 1/7 cosine 7 theta. All right, so if I take, just want to double check. This is going to be a negative, I believe. All right, so I've got uv, okay, uv, sorry, just making sure everything looks good. uv minus v du, so it's going to be plus 6/7. Yeah, professor, huh? Ultraviolet minus super voodoo. All right, so plus looks like 6/7 integral. Okay, so here's what I think we have to do for this one. I had one like this in our class. All right, so we're here, right? Now what we're gonna do is we're gonna do it again. All right. This is a really weird one. It's a specifically weird one. So let's do it again. So let's let u equal, again, e to the 6th theta. So du is going to be 6e to the 6th theta. All right. And then what we're going to do is go ahead and put dv again is cosine 7 theta. And then v is going to be 1/7 sine of 7 theta. Perfect. Okay, so let's kind of rewrite this. So I'm going to kind of squish this all in. Negative 1/7 e to the 6th theta cosine 7 theta plus 6/7 integral of, okay, so I'm not going to do integral yet. I'm going to put that in a big parentheses. uv, so e to the 6th theta over 7 sine 7 theta minus v du. So I'm going to get minus 1/7. Gotta put that 6 out front. A lot going on here, man. That's why you're gonna be an engineer, because you gotta pay attention to those details. All right. Okay, we're back to where we started, right? I hope you're still with us, Sam. Are you still with us? You better be. Okay, good. So now what we're gonna do is we are going to let. Okay, so this is I think I remember this. All right, so let me adjust this camera here. All right, so we can see everything. So what I'm gonna do is I'm gonna let this equal s. Okay, so you get this? So I'm gonna let this thing equal s. So then what I can do is I can say, okay, then s, another whiteboard, which I have. So I'm gonna have S equals, I'm going to go ahead and I'm going to multiply this out. So negative 1/7 e to the 6th theta cosine 7 theta plus, I'm going to go ahead and multiply that 6/7. So 6 e to the 6th theta over 49 sine 7 theta. I'm going to multiply the 6/7 minus 36 over 49. Now, instead of writing this again, I'm going to go ahead and write S. Do you see that? Because this is the same thing as this up here, if that makes sense. All right, so what I have to do now is I'm going to go ahead and add 36 over 49's S. Get this. That might be a miracle. All right, so 49 over 49, so 49 plus 36. We've got 85 over 49s equals, oh, this looks like an integral symbol, doesn't mean to be, equals negative 1/7 e to the 6th theta cosine theta plus 6e to the 6th theta. All right, so now let's see what we can do from here. It says, yeah, it's equal to S. All right, let's see what we do here now. Yeah, so now we just multiply by 49 over 85. Yeah, I know. I teach this course and I tell the kids, I'm like, I am not your superior. Like, we are in this together. All right, so S equals, so I multiply everything by 49 over 85. All right, so it's going to be negative 49 over 85 times 7. That's 595 e to the 6th theta cosine 7 theta plus, what's nice is if I multiply this by 49, those are going to cancel. So I'm going to get 6 over 85 sine of 7 theta, 6e to the 6th theta. And then what you're going to end up doing is, let me see if 49 over 595. Okay, and then 6 over 85. All right, so this is going to be S equals, it's going to be e to the 6th theta times cosine 7, oh shoot, cosine 7 theta. The cosine is going to be 7 over 85 plus, oh, we can, okay, hold on, no, I'm getting there. Okay, we can, because it's going to want the factored version. Like, we can take stuff out. So e to the 6th theta, the hell with this. All right. I don't even care if you're here anymore, Sam. I'm just proud that we did this. All right. So we're going to have S equals e to the 6th theta over 85. And then we're going to have negative 7 cosine 7 theta plus 6 sine 7 theta. Oh, there we go. That's what I'm talking about. So yes, I do know how to do that problem. All right, I see some Amherst kids here. This is Calc 2. All right, do you guys want to do some ACT prep? I haven't done any ACT stuff yet. Let me know. Let me know if there's any problems you need or anything else. Okay, if we want to do ACT or what are you thinking? Now, Sam, if only you had the answer key to check that out, that would be legit. Anybody else? Calc. Okay, you want to do some calc? That's perfect. We were just doing some Calc 2 stuff. All right, I was lost on the browse. Yeah, it's right. I put it into That's what I'm talking about. It's right. All right, what kind of calc do you want there, Michael? Okay, maybe take a screenshot of that, Sam. What kind of calc, dude? We can do limits, we can do derivatives, we can do integrals, we can do anything, dude. All right. Good call, Sam. No, thank you, my friend. All right, let me know. Let me know. What kind of calc? I was just doing some unit circle stuff, but we can do anything. Integrals. Perfect. All right. So let's start at. Then I have a trig sum. Okay. All right. So if we've got integral, so let's do integrals of just like 3x squared dx. All right, let's go ahead and take a look at this. So again, just kind of a crash course. So an integral is going to be the sum of infinitely small squares or rectangles from 3 to 7 that get you the area of the curve. So what I'm going to do is I'm going to do the reverse power rule. All right, so 3x squared, I'm going to go ahead and I'm going to add a power to these two, so it's going to be x cubed. Now I can put the 3 out there, so I'm just going to leave it here. It's kind of arbitrary. And then I divide by this power, okay? So what's going to happen is if I take the derivative of x cubed, I get 3x squared. So I'm going to go ahead and I'm going to evaluate that from 3 to 7. So what I do is I go ahead and I plug in 7. So I plug in 7, I cube it, and then I minus, and I plug in 3. So I minus the bottom one, and I cube it. All right, so 7 cubed is, I'm doing it in my head, not on my calculator off to the side. All right, 343 minus, all right. Briley, good to see you. Are you in any math? How's life going for you? So that 27. So then I've got, I actually saw your senior picture up on my counter the other day. I was wondering how you were doing. 316, okay? So 316 units squared, which makes sense because it's so freaking high up, okay? We're going to do, that class is really hard. That class is, I remember helping people in college and I like couldn't because it was all word problems and stuff, okay? What kind of substitution trig? Oh, trig sub. What kind of trig sub? That doesn't sound very fun. Let's do a u substitution. So if I've got the integral of, let's say it's x to the 4th times the sine of x to the 5th. Okay. So this one. Okay. So the integral of dt over the square root of 25 plus t squared from 0 to 5. Ugh. I don't. I have to look at that one. I have to take a look. All right. So from here, what I got to do then is I notice that the derivative of my inside function is actually right here. So the derivative of x to the 5th is 5x to the 4th. I notice that this right here is sitting there. So that prompts me to do u substitution. So I'm going to do let u equal, it's almost always the inside function or like the bottom of whatever you're doing. So the inside function here is x to the 5th. Okay? Type 2 if you recall. Oh, yeah. I am not inverse tan theta. I don't know. I'm thinking. I don't know how to do that one. I'm sorry. I put all my chips on the last one. So I let u equal that. So I'm gonna let du equal 5x to the 4th. So I'm gonna go ahead and get the x fourth by itself. So divide by 5. Okay. So it looks something like this. All right. So now what I'm going to do is I'm going to go ahead and substitute. Instead of putting x to the fifth, I'm going to put u, and I can substitute out this. So if what it looks like, if we kind of make it more clear, is this comes out. All right, so x to the fourth comes out, and dx comes out, and I'm just left with du. All right, x to the fifth comes out, and it becomes just u. So I'm left with sine of u du. All right, and then this 1/5 right here. Okay, so because this x to the fourth dx comes out, I put my 1/5 there. Okay, so I've got 1/5 instead of doing sine. Instead of doing the derivative of sine, which is cosine, I'm going to do, what do I take the derivative of to get sine? Now, obviously, it's cosine, but notice that if I take the derivative, it's negative, so I got to put this negative out there just to kind of negate that. Okay, so what I'm going to do is I'm going to go ahead and put x to the fifth back in there. So I'm going to get negative 1 over 5 cosine of x to the fifth. And then don't forget your constant of integration. Okay, constant of integration. Yeah, Sam, I know. Yeah, it's fun because Calc 2 is ridiculous. That's why. All right. All right. Do you want more integration there, Michael? Or any more thoughts? Riley, let me know if you've got anything. Okay, you're probably long gone, but all right. Okay. Let me know if you want me to do another integral. I can do one maybe that's different, or let me know. What time is it? I have no idea what time it is. I just have so much fun hanging out with you guys talking math. I lost track of time. Yes, related rates. Perfect. So, get up a problem here because it's kind of hard to come up with one on the. All right. So, it says, I go in here, a width of a rectangle. All right. So, let's go ahead and take a look at related rates. All right. So, the width of a rectangle is increasing at a rate of 2 centimeters per second. So, my width is increasing. So dw dt, which is the rate at which my width is changing with regards to time, CSM, is 2, it says, and its length is increasing at a rate of 3 centimeters per second. So length is increasing at 3 centimeters per second. At what rate is the area? Okay, so what rate is the area changing over time? When its width is 4 and its length is 5. All right. Might be the easiest related rates problem, but we got to start somewhere. Otto, you're here to learn a little bit of calc? You got any math questions? Don't ask me any of those like economics questions or whatever you're in. All right. So I got to find the area formula, which is just length times width. Okay. Yeah. So I'm going to go ahead and I'm just going to write that, and I'm going to take the derivative of it with respect to time. Okay, with respect to time. So I've got dA dt. All right. dA dt equals, I'm going to go ahead and do product rule. So the product rule is first, if I can spell, times the derivative of the second plus the derivative of the first times the second. Okay? So that's how we find that. So we're going to go ahead and we're going to do the first, which is length, times the derivative of the second, dw dt, plus the derivative of the first, so that would be dl dt times the second. All right. So I don't know what my area is with respect to time. That's what I'm trying to find. I know the length is 5 at this given moment. I know my dWdt is 2. I know my dLdt is 3. And I know my W is 4. So my dAdt equals 10 plus 12, which is 22. Looks like we're in centimeters per second. Okay. All right, what's going to happen is after the ACT, I'm probably going to get some prep questions for the AP exam for Calc 1. Okay, we'll just roll with that. I'll do specific days probably for the AP exam. All right, should we do some ACT problems? Otto, no, all right, Aubrey's here. Let's do some ACT problems. All right, let's see what we got. So the first one, number 97, let's take a look. All right, a little bit harder to read with the new setup. I gotta zoom in more because I just had that one calc problem that we had to zoom out on. All right. Of the 804 graduating seniors at a certain high school, approximately 2/5 are going to college. Approximately 1/4 going to college are going to a state university. Which of the following is the best estimate for how many graduating seniors are going to go to a state university? All right, let me just open up my answer key to make sure that I can get these questions confirmed. All right, here we go. So of 804 graduating seniors, so what we're going to do is we're going to go ahead and find what 2/5 are of the 804 people. All right. So I'm going to go ahead and take 804 times 2/5. I end up getting something gross. 1608 over 5, whatever that is. Approximately 1/4 of those. So I got to take 1/4 of that bad number. So I got to take 1/4. I actually would rather do this by hand. So I got to go ahead and divide that by 4. So 4 goes into 16 4 times, goes into 0 0 times, right? And it goes into 8 twice. Okay, so I get 402 over 5. 5 goes into 48 times goes into 2 0 times with 2/5 left over. So I think my letter is F. Okay, F. Finding 1/4 of 1608 over 5. 97. Let me take a look. 97 answer is F. Victory. All right. Next one. Let's take a look. We've got. I could probably cut these. I got to figure out a way so I can do this with the whiteboard. Whiteboard's way better. All right. What is the distance? Oh, yes. Distance formula. How many of you love distance formula? Not me. Okay. Don't memorize the distance formula. Okay. You can derive it from your understanding of Pythagorean theorem, but please don't memorize it. Unless you're a nerd. What is the distance to the standard coordinate plane between 1, 0 and 0, 5? Okay, so basically I need to find where are these points in terms of their relativity to each other. So from 0 to 1, from 1 to 0, 0 to 5. So if I just kind of map this out, I got 1, 0 here, and then 0, 5 is way up here. So the distance side to side is going to be 1, right? So I'm making a right triangle is what I'm doing. This is 1. My vertical distance is 5. So it's going to be 1 squared plus 5 squared equals my distance squared. So that's going to be my distance. So this is 26 is my distance squared. So my distance is the square root of 26. All right, square root of 26. Okay. E. Let's take a look. 98. Answer is E. Perfect. Now, if you want to do the distance formula, okay, you go right ahead. Okay. Oh, Breed. All right. Coming back, doing some more math. All right, here we go. The ratio. All right. The ratio of the radii of two circles is 4:9. What is the ratio of their circumference? Ooh, this is a good problem. All right. Heck yeah. All right. So if I've got two circles here, this one right here is 4, and this one right here is 9. Let's figure out what their circumference are. So their circumference equals pi times diameter, or 2 pi r. So that means this circumference is 2 pi times 4, and then this one is 2 pi times 9. So it says, what is the ratio of the circumference? Notice that the smaller one is first. Excuse me. So I'm going to do the smaller one first. So this is going to be 8 pi over the larger one, 18 pi. Cancel out the pi, you get 8 over 18. All right, so that's 4 over 9. 4 over 9. G. Looks like G. Hey, Michael, did you guys win your game on Friday? I know the girls did not on Thursday. My coffee's cold. All right. No. I think it came down to Parker's attitude. He wasn't super confident. All right. Let's take a look at the next one. We lost by 40. That's literally what he said. All right. That's what he said, like, was really anticipated. All right. Number 100. A circle in a standard XY plane. All right. So let's just take a look at the circle. All right. So equation. So I'll keep this down here. So equation of a circle. All right. So equation of a circle. So what we have is we have the basic x squared plus y squared equals 1. So this is centered at 0, 0. It has a radius of 1. Okay, whenever you start moving things around, that's when we shift our equation. So this one says tangent to the x-axis at 5 and tangent to the y-axis at 5. Tangent. Yeah, you too, Breed. So tangent at the x and y axis. That means it touches the x and y axis at 5. So what that would mean is, like, this would be 5. It would kind of touch it, right? Tangent to. So what I'm assuming that would be a circle centered at. What's going on here? Oh, it's what's going on here? Oh, my live. Something with my live is going on. Oh, I'm sorry. Someone in my live happened. They said they had to verify because it was doing something. Anyway, so it's centered at 5, 5. And then that means my radius is 5. Okay? Because it goes from the center and then it touches. So that's going to mean my equation is going to be y minus my y value. Right? My y value is 5. And that's squared. So that's how that differs from this equation. Okay. Well, x or y squared doesn't matter. They're both added. Plus x minus 5 squared equals, now here's the key. It has to be the radius squared. So this is going to be 25. All right. So it looks like I've got D right here. 100 is D. X minus 5, y minus 5. All right. Equation of a circle. We don't use it very often, but they love to test it. All right, let's do one more here. Let's do one more. Let's see what we got. Again, if you have any math questions, let me know. We're just running through a few ACT prep questions. Okay? Let me know if you've got any problems you want to work on. All right, we've got, which of the following statements describes the total number of dots in the first n rows of the triangular arrangement below? All right, 1, 3, 5, 7, 9. Okay, this is a weird problem. Some guy just sat in his office. He's like, how can I get this problem in there? All right, it describes the number of dots in the first n rows. All right, so basically we have to find the sum of the rows. So it looks like whatever. So let's say, sorry, this is Calc 2 here. We're just doing this. So we got a series here. So it looks like we start with 1 and it's odd, right? We add odd. So it'd be something like 2n plus 1, where we start at 0. Okay, so what that means is we have a summation of it starts at 0. So when n is 0, that's my first row, basically. Okay, so that would be 0 plus 1, so I'd have 1 plus. Our second row would be n equals 1, so it'd be 3, plus my third row here, my n would be 2, so it'd be 4 plus 1, 5. Okay, so 2n plus 1. So it says, let's take a look at our questions. The total is always equal to 25 regardless of the number of rows. That doesn't make any sense. The total is equal to twice the number of rows. No. This total is equal to 5 times the number of rows. This total is equal to the square of the number of rows. This one is weird. Let's take a look here. So let's take a look if we just made a chart. So the first row, because we really can't do much with this right there. D. All right, so if we plug in 1, we're going to have, in our first row, we're going to have 1. Then our second row, we're going to have 4. Our third row, we're going to have 5, 6, 7, 8, 9. Yep, we're starting to see it, right? Then we have 9 plus 7. There we go. And then 25. So yeah, looks like it's going to be D. Good job, Michael. All right. Hey, those of you in there, you were right on that. I know you were super close to getting that one. All right, it is 9:40. I've been on here over an hour. I will try to be on here nightly. Come back with your math questions. Everybody have a good night.